Good day everyone. For this video, magtatakal na tayo ng ating final term topics. So we have the fluid flow in pipes. So let's proceed sa ating PowerPoint. Okay, here is our PowerPoint presentation. So fluid flow in pipes. This is one of our final term topics. Okay, let's proceed. So we have here the Reynolds number. The transition from laminar to turbulent flow depends on the geometry, surface roughness, flow velocity, surface temperature, and type of fluid, among other things. Sir Osborne Reynolds discovered that the flow regime depends mainly on the ratio of internal forces to various forces in the fluid. This ratio is called the Reynolds number, and it is expressed for internal flow in a circular pipe. So yung ating Reynolds number is represented as R, a big letter, capital letter E, R, and small letter E, or RE, is equals to inertial forces over sa viscous forces. So, i-expand pa natin itong formula na ito. So, we have the average velocity times the diameter over the velocity. Okay, wait lang. Okay, so next is yung another formula niya in terms of kinematic viscosity. Kumbaga yung ating kinematic viscosity is the rho over the nu, or yung ating absolute viscosity. So we have rho, or yung ating density times average velocity times the diameter over the nu, or yung ating absolute viscosity. The Reynolds number at which the flow becomes turbulent is called the critical Reynolds number. The number, or the value of the critical Reynolds number, is different for different geometries and the flow conditions. For internal flow for a circular pipe, or in a circular pipe, the general accepted value of the critical Reynolds number is 2,300. For flow through non-circular pipes, the Reynolds number is based on the hydraulic diameter, or yung ating D sub H, and as defined as 4AC over P. Yung AC natin is yung cross-sectional area ng pipe, and then yung P is the wetted perimeter of that particular pipe. And for the circular pipes, yung ating P, or yung wetted perimeter, is pi D, and then yung AC natin is pi times D squared over 4. So here another derivation ng ating formula para sa Reynolds number. So again, Reynolds number, it is a dimensionless number, which is the ratio of the inertia force to the viscous force. In practice, flow velocity at any cross-section approaches zero in the boundary layer adjacent to the pipe wall and varies across the diameter. The flow velocity profile has a significant effect on the relationship between the flow velocity and pressure difference developed in the head meters. Thus, Sir Osborne Reynolds proposed a single dimensionless ratio known as the Reynolds number as a criterion to describe this phenomenon. This number, RE, is is expressed as density times velocity times diameter ng pipeline over the absolute viscosity. So here are the representation as it, and then ito yung ating formula, usual formula. Okay. So since napag-usapan natin yung ating Reynolds number, which is ginagamit para makuha yung transition or yung parameter ng flow natin. Kung laminar ba siya, turbulent, or in transition flow. So yung laminar flow, the flow in which the fluid particles moves in the same direction as So ito ay isang laminar flow. Ang turbulent flow naman, when the flow in which the fluid particles move randomly and in any direction. So, meron tayong figure to represent those definitions. So we have the laminar flow, so this one, and turbulent flow, this one. Whenever the Reynolds number is less than 2,300, the flow in the pipe is generally laminar. Whereas the values greater than 2,300, the flow is usually turbulent. So next, head losses in pipes. It may be classified into two. The major head loss, which is caused by pipe friction along a straight section of pipes of uniform diameter and uniform roughness. And the minor head loss, which are caused by the changes in velocity or direction of flow and are commonly expressed in terms of kinetic energy. And then, meron tayo ditong formula used in major head loss. So, kung hahanapin natin yung major head loss, we have three different formula na pwede natin i-incorporate sa solution. So, meron tayong Darcy-Weisbach formula. Kumbaga, pipe friction equation ito. Meron tayong Manning's formula. And then, last, yung Hazen-Williams formula. Mostly, effective itong Darcy-Weisbach formula, ginagamit ito sa ating pipe friction equation. Itong Manning's formula, to siya? Effective ito sa ating sanitary na field. Kumbaga, doon outside the household. Or yung mga kanal, yung mga dams natin, yung mga ganun na klaseng mga parameters or problems. Next, yung head loss in pipes with regard sa minor head loss, which are caused by the changes in velocity or direction of flow and commonly expressed in terms of kinetic energy. So meron tayo ditong causes of minor head loss. So we have sudden enlargement, gradual enlargement, sudden contraction, and then last yung bends and standard fittings. So next is yung ating water flow in pipes. Pipes is a or hollow cylinder, usually but not necessarily of circular section. It is used to convey substance which can flow. Head loss refers to the measurement of energy dissipated in the system due to a friction or any other energy losses. Next, the amount in discharge is the amount of fluid passing through a section of a fluid of a stream in unit time. So again, yung ating formula sa discharge is equals to area times doon sa velocity. Okay. Area or cross-sectional area. And then yung V is the mean velocity. So again, balikan natin yung losses in pipes with respect sa major losses due to friction. meron tayong Darcy-Weisbach. Ang kanyang formula is H sub F, or yung head loss natin dyan, is equals to F L V squared over 2G times D, or HF is equals to 0.0826 FLQ squared over D5. Depende kung ano yung given dun sa problem natin. So, kung given ang velocity, ito ang gagamitin. Kung given ang ating discharge, ito yung gagamitin natin. So, sa Mannings, we have head loss na 6.35 n squared LV squared over D to the power 4/3, or 10.29 n squared L Q squared over D to the power of 16 over 16/3. So, pag sinabing Mannings and then given ang velocity, ito ang gagamitin. Once given ang discharge, ito naman ang gagamitin. So, yung V natin, mahanap din natin siya with this equation. So, 1 over N times R to the power of 2/3 times S to the power of 1/2. And then last, sa ating Hazen-Williams, ang ating formula para sa head loss due to friction is equals to 10.67 L Q to the power of 1.85 over C to the power of 1.85 times D to the power of 4.87. So bungkig itong mga numbers na to, pero dapat ninyong ma-memorize or be familiar with these equations. Yung V natin, makukuha natin with this formula, or yung velocity natin, ang formula is 0.8429 C times R to the power of 0.63 times S to the power of 0.54. And then yung discharge, ang formula, 0.2785 C times D to the power of 2.63 times S to the power of 0.54. For circular and non-circular or non-circular pipes, yung D natin is equals to 4R, yung R natin is radius, or yung R, and then yung R natin is equals to area times perimeter, or yung ating wetted perimeter. So ito yung ating mga representation. Yung H sub F natin, head loss sa pipes. Yung F is the coefficient in terms sa ating friction. L is the length of pipe in meters. V is the velocity of the fluid. G is the gravity. Q is the discharge of fluid. D is the diameter of the pipe. N is the coefficient of roughness. Dito natin magagamit sa Mannings. R is the hydraulic radius. Ito din. Magagamit natin sa Mannings and then sa ating Hazen-Williams. R is the hydraulic radius again. P is the wetted perimeter. A is the area of the pipe. S is the slope of the hydraulic gradient. Magagamit natin sa Mannings and then sa Hazen-Williams. And then C is the coefficient of discharge. So for may na late dito. So yung ating slope of hydraulic gradient dito sa ating Mannings is equals to head loss over the length of the pipe. So next is yung ating pipe connecting reservoir. So yung mga head losses formula dito is Darcy-Weisbach, which is equals to 0.0826 F, or yung ating friction times length times a discharge to the power of 2 over D to the power of 5, or F LV squared over D times 2 times G. And then yung may Mannings tayo dito, HL is equals to 10.29 n squared L Q squared over D, the power of 16/3. And Hazen-Williams is equals to 10.67 L Q to the power of 1.85 over C to the power of 1.85 times D to the power of 4.87. Next is the pipes naka-series and or parallel. Series is when a pipe of a different diameter are connected end to end to form a pipeline. They are said to be in series. So meron tayong representation. Ito. The total loss of energy or head will be the sum of the losses in each pipe plus local losses at connections. Okay, ito din series. Parallel. Pipes are said to be parallel when they are so connected that the flow from the pipe branches are divided into two or more separate pipes and then reunited in a single pipe. So nagkamali ako kanina. So series and parallel ang ito siya, ito and ito. Para sa series series na figure is this one. So, dito na muna magtatapos yung ating lecture regarding sa ating final term topic. Next naman is yung ating pipe discharging from reservoir, pipe connecting to reservoir, pipe connected in series and parallel, mga illustrative or problem solvings nito. Okay, so thank you for listening. See you next video.